Hello, Maurieo! In this video, I'm going to measure the radius of an arc. Now, when we're doing or encountering things in the field, sometimes it's very difficult to measure the radius of an arc. Take, for example, this little bracket here on a picnic table that I'm asking students to measure up. What is the radius of these circles in here? How do you do that? How do you measure that? There are a number of ways, and in this video I'm going to show you a couple of ways. Now, the most itchy nose there, I don't know what that indicates. I have to look up my body language books. So there's a number of ways of doing this. I'm going to show you a way using this photograph, but before I do that, I think we should go to our old friend Google and determine radius of an arc. So let's just zoom in here so that we can see this really good, and you don't have to put up with me scratching my nose all the time. So let's just go in there and go enter for the search there, like so. There it is there. And I usually, with these particular ones, go to the images first. And straight up, we come up with this image here, which looks pretty good. And it says there, have you ever been stumped trying to figure out the radius of a large arc, or any arc really? And because we can't actually sort of measure from the center line in the example that I've given you there, and so the information that we have, and here it is, it sets it out for you what to measure, and then a little bit of a calculation, and that'll give you the radius of the arc. So that's one way, but I'm drawing these ones up. So this is another way that I've sort of developed. So the first thing we do is you just take a photo of it like this here, and then you measure what you can. Now I just measure this here because what I'm going to do is I'm going to try and scale that up, scale that so that that's right. So first of all, I'm going to draw a line. I'm doing this in AutoCAD, obviously, a single line here. I'm just going to draw that line, say from about there to there. Okay, like, oh, that's not that, because that's single line text. I'm going to go alpha line and go from, say, about there to roughly there. Now that, yeah, it should be there. And then I'm going to go out to there like that. Now, obviously with a photo you can get a bit of distortion. Now let's, there's that line there. Let's just get our properties back up there. So that line there is 83.9824. Okay, so that's 83.9824. So I'm going to get my calculator out, and what I'm going to do now, we can actually go into AutoCAD. There's a calculator there, and we can go calculator, and quick calc, and put it in, and we get a calculator that comes up. So just looking at the properties of that, as I said, I'll just select that there. Okay, that's 83.9824, and I want it to be 100. So obviously it's got to go bigger, so 100 divided by, so that's, which one's that? The slash is the divided by, and then we'll type in this number here. I might even be able to click on that. No. Okay, I'm going to type it in. 83, oops, into here, 83.9824. enter. And you see that gives me 1.1907, what that number is there. It also might pay just to do a similar calculation here, because you can get a little bit of distortion in different directions, so it might be just paid to get an average. Okay, so that's in there like that, and so that there is what have we got there? 115.1361. So I'm going to go, so again we go 135, oops, slash, so, oops, I should have noted that other one, sorry. Well, I'll do this now, 115, oh, there it is, the other one's up the top there, that's good, 115.1361, oh, we want to go 135 slash enter, and that gives me 1.172. So I think I'll take an average of those, so I'll go plus 1.19072568 is that, and then I'll divide that by 2. Okay, and that will give me 1.18. So if I scale it up by that there, that's going to give me a pretty close approximation to that. So let's just go here like that. We'll select that and it will scale it up. SC, enter. And I'll just use that point there as my base point, and then I'll type in 1.1816255.4. Enter. Okay, and now I'm going to click on there, and what have I got there? 99.2358, so that's within a millimetre, and then that there is, oops, I'll just click on the one click, I call it, I don't quite know what it is, and that one there, 136, so again that's within a millimetre, so that's pretty good. Okay, so now it comes to trying to do these circles here. Now what I do is, first of all, I try and just draw a circle that approximates the radius of these. So I'm just going to put one in there like that, and I've got that one there, okay, and that circle there, I'm going to put the radius on there because I'm assuming that these are circular arcs, so they've always got to be at right angles to these points, because you know, like it's always a tangent, so the radius is always at right angles to a tangent, so it's got to go through there, so that means the center of the curve must be on there. So that one there, just looking at that, that's got a diameter of 138.786, so I'm probably going to go with that there as 140. Okay, so that's a circle 140, and then what I'll do is I'll just move that up the line a little bit until it sort of fits round about, well, actually what I'll do is I'll go C, enter, and I'll do a circle just there, 140, okay, oops, that's not working out quite so good, delete. So that's a radius of one, that there should have a radius of, oh no, it's a radius of 70, sorry, that was a diameter of 140. course. So I'm going to do one C, enter, and I'm going to just click on the end of that there, and that's going to be 70. Okay, so that means that the center of this circle here, I'm just going to put that up there, put it out of the way, and we'll put it on there at that intersection, and I can take that one out of there, delete. Okay, and now I'm going to do this circle here, which will be right angles to that one there. So I'm going to go C, enter, and I'm going to put something all round about here, and put that onto that curve there. And yeah, maybe put it on the end there. No, I think just matching it, I think there's going to be a better fit. And that there's got a radius of 51. So clearly we'll make that one 50. Okay, all right, and then we'll do C here, there of 50. Okay, and we can see that then we'll put that one there, right there, and that's not fitting too bad. So that gives us the radius of that one there is 50, right? That's a 50, and that's a 70. All right, so now we've got a little circle that's got to go in here, okay? And so I'm just going to draw that randomly, C, enter, let's put one in here that sort of fits in there, and it's going to just try and match it in there, like, I'll turn off my ortho here so I can move about a bit more freely. Okay, so that one there, yeah, I reckon, yeah, it's not too bad there. Okay, and the radius of that one there, what radius have we got there? 30. So we'll just, we've got that at about 30 for the radius, but what we know is that the radius of these two must meet at a right angle. So if that one's 100, sorry, if that one's 70, and this little one in here is a radius of 30, then it must be, we go C, enter, so 70 plus 30, where's that little radius? Oh, yeah, 70 plus 30 is 100, which is there. And then this one here is, I've got that at 50 plus 30 is 80. So C, enter, and that's 80. Okay, so the center, if you draw a line from the center of this circle here, from there to there, that will be the center of that circle, and then the line must go back to there. They will all be, for them to meet at right angles, they have to be on the same line, and then we draw in here. So I'm just going to take these ones out of here now. I've finished with those. Delete, take those out of there. And then I'm going to just go C, enter here, and then put my 30 millimeter curve in there. And that should all line up very nicely. And then I'm just going to trim out what I don't need. TR, enter. So I don't need that. I'm not going to need that, or that, or that, or that, or that, or that for that matter, or that. And there you go. Oh, and here, this should trim out nicely as well. Okay, and I'll just thicken this up a little bit. Oh, I don't want to do that. Control Z. Okay, so that's finished with the trimming. And in here you can see that this has got this. Oh yes, I need to hit more than them at once. So I'm just going to put that in there and that in there like that. And we'll just thicken that up a little bit with the line thickness somewhere. I'll just go to the home button and I'll do my line thickness and we'll give it a 0.5. Turn on the line thickness, might be a bit helpful. And there you can see that I've got that nicely drawn with the correct geometry and some nice even dimensions which would be easy to draw. So we've got, well, we can just click on the properties here. We've got a radius 70 mils there. I'll click back to one. A radius 30 mils there. And a radius 100 or 50 mils there. So there you are. That's using photography and a bit of Euclidean geometry that enables you to measure those very accurately, to draw them, and also for the person that's setting them out in the machine shop, it's going to make them, you know, with that diagram and that information, it's going to make it very easy for the person to draw that up, and you know, from scratch or in CAD or whatever. Very much dependent on your measurements. I've sort of possibly should have perhaps come inside the world there, but nonetheless you can see there how that comes up with a very nice smooth sort of drawing, exactly how you do it. So that's my way of measuring up the radius of an object and drawing it up so that it's nice and easy to draw. So yeah, that's the end of that video. Hopefully now you've learned a little bit about scaling photographs, to use that as a method of measuring things, as well as the use of Euclidean geometry principles to come up with a good diagram that's easy to set out. So cheers, see you.